Moving on to the question 18, it is the conversion of degree and radian measure, and also to find the arc length. Here we have a real world problem about transportation. A traffic roundabout has a diameter of 200 meters. How far does an automobile travel in the roundabout if it goes 1/4 of the way round? So now, what is the diameter over here of the roundabout? Its total distance is 200. So we need radius. Radius will be half of it, 100 meters. Now, if you remember, the arc length, how long does it travel, is basically the arc length. They're told 1/4, right? Imagine the car started over here. It's going 1/4 only, quarter of it. So that is done. How much is this degrees? So if you recall, 90 degree would be 1/4 of a circle, and degree theta is 90 degrees. But the problem is we cannot take it in degrees. For the arc length formula, L is r theta, we have to take this theta in radians only. So r is easy, 100. But what about the theta? We need to take in radians. So what is the total circle in radian? It's 2 pi or 360 degrees, right? Or we can write pi is equal to 180 degrees. Pi value in degrees is 180. So how much is 90 degree? In radians, unknown value. How much will be 90 degrees? Cross multiply. So this would be very straightforward. It is just 90 divided by 180. It will be half. Or pi by 2 is the answer. Just divide both the sides by 2. We'll get 90, right? So it's pi by 2. Always remember these few things. 90 is pi by 2 radians. 180 is pi radians. 360 is 2 pi radians. Now what about 45 degrees? It is pi by 4. So these are few basic things to remember. And also there is one more thing. What about 270 degrees? That is basically 3 pi by 2 or 3 by 2 pi. And yeah, so that is about it. All this 90 is pi by 2 pi, 1.5 pi or 3 pi by 2, and then we go to 2 pi. So now we just substitute theta in radian. 90 degrees would be pi by 2. So here it'll be 50 pi. That would be the answer. But now they might require in a value. So what you need to do is multiply this as 3.14. But I'll show it in calculator. All you would be doing is writing it directly 100 times pi. That is shift and this symbol here, 10 to the power symbol, and by 2. So the answer is 50 pi. But if you press SD, you will get 157.08. That would be the final answer. You can see here it's 157.08 meters. So the arc length, if the car is traveling a quarter of it or 1/4 of it of the roundabout, it will travel 157.08 meters. Now what about this one? It's about clocks. Now this is interesting. The length of a minute hand. Now you know watch clocks, right? There'll be two hands. Now imagine it is 3 o'clock. So this is 3 over here. That'll be the hour hand, and then at 12 will be the bigger hand. This will be 12. And you know at 1, 2, 3, 4, over here will be 6, 9, 10, 11. Now you might have heard this. Sometimes your friends will tell you, look at 3 o'clock. If you're talking to them over here and your eyesight is over here and over here, 3 o'clock would mean to your 90 degrees at the right. You look over here. If it's at your 6 o'clock, that means looking at backside. Or if it's 9 o'clock, look at your left. So sometimes like a code word, look at it 3 o'clock, look at it 4 o'clock. That means over here, look at so much degrees, basically. So now here, since this problem requires the minutes and the hour hand, let's just plot this, all the clock timings, 7 and 8. It may not be very accurate, but just the gist of it. Now these are all 5 minutes, isn't it? And here, what is the thing? The minute hand is how much? 5 inches. That's basically the radius. So this is the radius, not the diameter, isn't it? So radius is given as 5 inches. If the minute hand rotates from 12 noon to 2:40, so 12 would mean the small hand also will be over here. But anyways, from here till 12:40, that means half an hour, 40 minutes. It'll go over here. Can you see that? It has traveled so much. from here to here. How far does the point move? What is the degree here? Now, what you can do is, 40 minutes is basically 1, 2, 3, 4, 5, 6, 7, 8, right? From here, you can just count it till 8. So, 8 out of how much? 12. But the total circle is how many radians? I'm not dealing with degrees. You can do it in degrees, 360. But now I'm dealing with radians. Why? Because we need for arc length r theta. Theta must be in radians. We know r is phi. But the theta degree we need, so that time we can find this length of the arc. See, this whatever is the curved arc, right? The traveling, we can find that. So here, we just multiply by 2 pi. Because 8 12th is done. 8 out of 12 is done out of 2 pi, right? Or you can also do like this. 2 pi divided by 12. Why? Because each part is made into 12 units. So total is 12 pi. So whatever the answer we get over here, it is how much? 1 by 6 pi, isn't it? So each of this segment, 5 minutes, is 1 by 6 pi in radian. This is 1 by 6 pi. So how many are there? Till 8. So multiply this by 8, you will get the answer. It will be 8 by 6 pi. So I can write over here, or you can write the same thing. That is also the same thing. Up to you. So I'll write 8 by 12 because 8 from here to here, it's from 12 to 8 into 2 pi, that's of total circle. Now just put that in the calculator, you will get the arc length. All I do is write it 5 times 8 by 12 multiplied by 2 pi, shift and the symbol, and you need to press SD. It's 20.94. I mean, they have rounded off to the nearest 10th here. They have not mentioned, but anyways, you can write it 20.94 or you can write it over here 20.9. So I hope this is clear. See, now we have taken it as 8 by 12. They have taken 2 by 3 because they've simplified and taken it. It's fine. But as long as you understood the concept, that's the thing. Now, if you have remembered an 8 by 12, now if it changes till 10, imagine it was till 10, then you just change this 10 by 12. That would be your answer. Now the conversion, the very easy part. These are very, very simple. I'll write the conversion. See, we know pi is 180 degree, right? So if I have degrees over here, and sorry, degrees, and I want it in radians. So what do I do? So I need the answer in radians, right? So I need to cancel out degrees. So if I divide something by degrees, does this cancel off? Yes. So radians must be above, isn't it? So radians will remain. So the answer will be radians, right? Whereas if I have the terms in radians now, I need to cancel it out. So down whatever is there, it must be in radians. And now above, if it's degrees, then the final answer, what happens? It will be in degrees. That's it. That's the concept. Now, if I have, say, 90 degrees, I need to convert to radians, right? The answer must be in radians. So what I do is, the conversion factor is just this. It's either pi by 180 because pi is 180, right? Or you should use 180 by pi. Now, which would you multiply? Here, since it's 90 degrees, right? Degrees is down. What is the degrees? Degrees is always 180, right? 180 is down and pi will be up. And that's it. Now this cancels off. It will be pi by 2. Now imagine I'm just converting this pi by 2 into degrees now. This is how much? Radians. So radians must be down. If it's degree, it can't be up. It must be down. Opposite. See, radian, down. So I'll write pi down. What goes up is degrees. So if this is in radian, first you write degrees. If it was in degrees, first you write radian. It's just the inverse. See, now this cancels off. 180 divided by 2 is 90 degrees. Yes, this is the answer. So now over here, what we have is 18. So what do you do here? Multiply this by pi by 180 degrees because degrees must be down. This as well. Pi by 180 degrees. So one time it's 10 times. So it's pi by 10. That's it. That's the answer. Over here 6 1 times 6 3 times. It'll be 30. Pi by 30 degrees. Pi by 30, not degrees, just pi by degree, and degree cancels. This and this is cancelled. So it's in radians. Now this is in radians. You don't need to write in radian. Whenever we have in pi, it's always understood to be radian. Pi by 10, pi by 30. Similarly, you can solve all these. Doesn't matter if it's a minus sign. All you need to do over here is pi by 180. Here as well, multiplied by pi by 180. But what about these? You have radian over here. Whenever you have radian, you can't multiply pi up. It must go down. So 180 degrees is up. Here as well, 180 degrees is up, divided by pi. So this pi cancels. All you do is multiply this by 180. See, whenever you have radian to degree, it's very simple. Just don't write this pi, just multiply whatever is there to 180, because pi is 180, right? Over here, you can also do this. Just divide this by 180 and write in terms of pi. So that will be the answers. You can just use your calculators. I'll show you in calculator, it's direct. All we do is 4 pi. You can write it as it is, and 180. Sorry, this is 180 by pi. And that's the answer, 720 degrees. I just remembered one thing. Some students use this symbol for minus, and this is also there for minus. I would not encourage you to use this. Yes, you can, but this is for other purpose. This would be the most appropriate one to use, minus. So try using this for minus, multiplication, division, addition. Never use this one, because I saw one of my students in school, he was using it. So I just realized somehow the answer was not coming right. Then just use this, it'll be always right. So here for this, it's 720. For this one, all you do is just change this first part and you will get the answer. So these are the answers. You don't need to write all this because it's an electronic part. All you need to do is put in the calculator and solve it up. And what about this? Again, it's very simple. I'll write the conversion factor. You do it by yourselves. All you do is 180 degree, because radian is the radian can't be, it's not possible. If it's radian, degree divided by radian. Even over here, it's 180 degree by radian. And over here, it is pi by 180 degrees because it's degree first. So they must be not on the same line, it must be up and down. So that'll be the answers. Here you go. And now we have some simple problems again about arc length. We know what is the formula for arc length. L is given by r theta. What is the radius? It's 4 inches multiplied by theta is in radians, so it's very simple. All you do is put in the calculator, you get the answer. It's 8 by 3 pi, or you can press SD in the calculator, you'll get 8.4. Let me show that to you. All you do is see 4 multiplied by 2 by 3 pi. And then when you press equal to, it's 8 by 3 pi. When you press SD, you get it as 8.37, which is written as nearest 10th. Okay, they have clearly mentioned it's nearest 10th. You have to write SD and write this value, 8.4. And what about over here? You need to find the arc length. It's again, same thing, same formula, r theta multiply 3. And this angle, you get the answers. Over here, all the methods are there. You can follow this. Now, again, some real world problem. Find both the degrees and radian measures for the angle through which the hour hand of the clock rotates from 5 a.m. to 10 p.m. Now, look over here. They have clearly told we are not finding the arc length or anything, just the hour hand. So, hour hand, it's from 1, it's not hour hand, hour hand, okay? Hour, 1 hour, 2 hours, 3 hours. So, here it is 4, this is 6, and this is somewhere 5. So the 5 a.m. is in the morning, so it's something like this. Now to go to 10 p.m., it's just not going over here. This is 11:10, right? It's just not going here. This would be 10 a.m. now. It has to go once entirely, and then when it comes back, it will be 5 p.m. So from 5 a.m. to 5 p.m., it has to do one complete circle, that is 360 degrees, and then it has to go over here. So what is from 5 to 10? It's just 5, isn't it? So here we are 8, 7, 8. So 1, 2, 3, 4, 5. But it has done 1 12 by 12 plus 5 by 12. What is this? Because it has done full rotation, right? It has done 12 by 12. That means 12 by 12, 2 pi, right? It is all thing multiplied by 2 pi. Why? Or you can do it in 360, because we have to do degree and radian, because I did in the last problem in radians. I'll do it as 360 now. What you're doing is whatever is rotated must be multiplied by this total degree of the circle. That is 360. But here, since it's going 2 times, 12 by 12 is done. That is 1 plus One more time, it is just going five of this, 5 hours. 1, 2, 3, 4, 5. By total is 12. So now this will be multiplied by 360 degrees. So the answer, whatever you get it over here, okay? Yeah, it'll be 360 plus, so whatever is the angle. So now there's another way to do it. I'll just write it out over here. From 5 a.m. to 5 p.m., it's 360 degrees. One complete rotation is done. Plus, how much does it go from year to year? How can we find that? Total is 360, right? And how many hours are they? 12 hours. So it'll be 12, 3 times 30 degrees. So here you can see there is 1, 2, 3, 4, 5 hours done. So 5 hours into 30 degrees would be plus 150 degrees. Okay. So here it will be 360 degrees plus 150. That will be 400 and, sorry, not 460, 510 degrees, isn't it? It will be 510 degrees when you add it up. That's the answer. Here as well, if you multiply this 360 plus 5 by 12 multiplied by 360, here 12 one time, 12 30 times, and it will be 360 plus 150, that is 510 degrees. It's going to be the same answer. You can just put in the calculator and check it. Now once you know this, all you can do is convert 510 degrees multiplied by pi by 180. That's it. Now that would be the answer. So here will be 51 by 18. You can just put that in the calculator. The table of 3 goes. So that would be the answer. We'll just put that in the calculator as well. 510 divided by 180 multiplied by pi. Pi will be in the numerator or up. It's 17 by 6 or 8.9, but we'll write it in radians, so it's 17 by 6. Table 3 goes 17 times and 6 times, isn't it? So that is the answer. Now, okay, I forgot to tell you one important thing. See here, usually how do we take the degrees? It goes in this left side, isn't it? So when we take from the left side, okay, this is 90 degrees and all that. But now, how does the clock move? Clock is moving to the right. That is a minus. So whatever answer you get minus. And remember, whenever we have clock problem, we just take negative of it. When we are solving the arc length, we don't take negative because length is just positive. So if they are telling how much length is rotated, you just take the positive value of that. Doesn't matter. You're not taking minus sign because we're finding a distance. It will be always positive. But now they're just telling the degrees. How much degrees is gone? This is the correct answer. You can see here. See, it's 510 degrees and 17 pi by 6. But we take the minus because from 5 a.m. to 10 p.m. it goes in the clockwise. It is the opposite side of measuring the degrees. That's the only thing. But as long as you understood these values, that's fine. And since it's choices, remember whenever your clock problem, they are just giving you to find degrees and radian, choose the negative answer. Now here we have a truck with a 16-inch radius wheel which is driven at 77 feet per second, that is 52.5 miles per hour. Find the measure of the angle through which a point on the outside of the wheel travels each second. Round it to the nearest degree and the nearest radian. This is important. We are just finding arc length again. L is equal to r theta. That's all we need to do. And we know the radius is how much? 16 inches. It's given. Let's just write 16 multiplied by what is theta in radian. Now, first thing, 16 inches, and over here they have given feet. How do we convert feet to inches? So, 1 feet is 12 inches. They tell 5'10", 5'11", 5'12" is basically 6 inches, right? So here we have 77 feet per second. Now they also mentioned how much travel it outside per second. So let's leave it as it is, okay? To find this 77 feet in inches, just multiply this by 12. So that is the answer in terms of inches per second. They are asking us to find the angle. So theta is unknown. Whatever the value we get over here is basically the length. That is the measurement in terms of distance, isn't it? So that is the length L value. So over here it's 77 multiplied by 12. You can multiply and get the whole number, or I just written it like that. That's up to you. And now just solve it in the calculator. You can either type this out as it is. I'll show you this way. 77 multiplied by 12 equals, that is alpha n equal to 16. multiplied by x, that is the theta value, you get the answer here 57.75. Or what you can do is, you can just, if you don't want to put that x and everything, 77 by 12 divided by 16. Any one divided, it's fine because it'll be divided by both of them. That'll be 57.75. Now, what is that 57.75? They have told nearest degree and radian. This is in terms of radians, guys. This is in terms of radian. Okay, radians. Now here you might be thinking there is no pi. You don't need to write in terms of pi, but whatever is this answer is in radians itself. So this is one done. Nearest radian. Okay, nearest radian, you can round it off to 58. Let's leave it like that because we'll first find the degrees. And now what is the degrees? It's just conversion, 57.75. This is not degrees, sorry, it's a radian. I'm so sorry I put a degree over there, I don't know why. Now multiplied by, to convert to degree, you have to multiply by 180 by pi. So just put this in calculator now. Now whatever is this answer, 57.75 multiplied by 180 divided by pi, that is shift and the symbol here, and press equal to, it is 3009. Let's look into the answer. It's 3009 degrees to the nearest degree. So that is how, and over here to the nearest radian, it will be 58 radians. But when we convert it, don't take the 58, let's take the actual value and convert it, and that's the answer. So this is how we easily solve it up. Now whatever the 77 was there, instead of feet, we need to convert to inches and then use the formula. Length is, over here they have written S, it's up to you. Length is r theta. We have the length, the total length, that is 924, that's 77 multiplied by 12. And radius is 16. Theta is not known. Whatever the answer you get, remember that is in radians. So we convert it to degrees. We got both the forms here. Now about planets, Earth makes one full rotation on its axis every 24 hours. Yeah, that's a day for us. How long does it take Earth to rotate? 150 degrees. So now whenever Earth rotates completely one circle, 360 degrees in its axis, it's one day. But now they're not talking about one whole day, about 150 degrees only. So look at this. So how many hours, right? So it will take 360 degrees is how much hours? 24 hours. So for 150 degrees, how many x? Just do cross multiplication rather than any other things. So you just take the x to the other side. It will be 24 multiplied by 150 divided by 360. Or you can also understand one more thing. Now we know 150 degrees out of 360 is there, multiplied by 24 hours. This is also the same, but I mean this is much better cross multiplication. Okay, you will get the answer here. So it is 15, 5 times 12 times 12, 1 time, 2 times, it will be 10. So 10 hours would be 150 degrees. For the Earth, 10 hours, you will get 150 degrees. The same thing with Neptune. Neptune makes a full rotation on its axis for every 16 hours. So full day, that's 360 degrees in 16 hours. What about 150 degrees? X. Cross multiply. It'll be again now here x is equal to 16 times 150 degrees by 360 degrees. Just the same thing. It is over here 5 times, and over here we have 12 times 12, 3 times, and over here we have 4 times. It'll be 20 by 3. You can just put that in the calculator, no need of doing it. So it'll be 20 by 3, that is 6, nearly 7, somewhere 634. Okay, 6.6666 hours. You can just put that in the calculator, you get 6.6666. That's 6 2/3. So here it'll take 10 hours, Earth will take 10 hours to rotate 150 degrees, and Neptune on the other hand takes only 6 hours, nearly 7 hours. So that's how we would solve it. And the last problem of this topic, if a surveyor's wheel with a diameter of 19 inches, diameter is given, so what is radius? 19 by 2, that is 9.5 inches, okay? Completes 5/6 of a rotation. What is the total distance traveled in inches? Okay, completes 5/6 of the rotation, the radians, basically 5/6 of 2 pi is done. Okay, because 5/6 of rotation, now imagine this is the thing, it's not fully done. If it was full, it'll be one time. 5/6, nearly it's done, but not. So total is 2 pi. In that 5/6 is done. Now imagine I tell 90% of the total rotation. So I'll write 90% of 2 pi, right? So that is the thing. Same way, I have 5/6 of 2 pi multiplied by what is the radius? It's 5 by 9.5, because L is given as r theta. So what is the total distance traveled? Just multiply this much, you get it. And nearest 100 they have told. So we put in the calculator, it's 9.5 multiplied by 5 by 6 multiplied by 2 times pi. The answer is 49.74 inches, because it's in inches. Now remember here, this is important, 5 by 6 into 2 pi, not just 5 by 6, you have to multiply with the total circle. So total circle is given by 2 pi. And since we are using theta, remember here we cannot use degrees, we have to use radians. I hope this is clear. We had plenty of problems, and that is the end of this particular topic.